Okay, so we're going to start our next topic here, and I call, or this Unit 2 topic, I should say. And it starts off with just some general graphing transformation rules or things that we should know just in general before we start applying them specifically to exponential and logarithmic functions as well as inverses. So what I want to kind of cover, and some of it maybe is from last year and some of it might be new, is what do these transformations look like? So whatever your function, as long as you have a function, f of x, what happens if you try to graph this transformation? In other words, you think about that negative x inside your function. And, putting a negative x or the opposite of an x into a function to see what happens is an even odd test. Right, and so you might have some idea of what's happening, but so this idea of putting x as a negative, think about like what would happen if all of your x's became their opposites. So here's your x-axis and here's your y. So all of your positive x's became negative and all your negative became positive. In other words, they're switching places. Well, this motion of switching places is exactly what's happening in terms of letting that y-axis become a line of symmetry. So anytime you see a transformation like this, that's a reflection across the y-axis. And if you don't notice a change, like if I'm thinking in particular of a parabola, right? If you reflect a parabola across the y-axis, you get the same image. Well, yeah, that is because your x's and your negative x's behave the same way. Well, that's a property of an even function. So, so that's why there's that kind of connection maybe with what you've seen before. It's a reflection across the y-axis. Okay. Now, the thing is, you don't have to be an even function for this still to work. So, so like, for example, if your graph looked more something like this. So let's say you have, go to a different color. So let's say your graph looked, it was like something like this and then this. And maybe this piece was just like straight across. So you could reflect that across the y-axis. So its image would now look something like this. Right? So it doesn't have to be an even function for you to be able to still reflect it across the y-axis. Okay. Now, if the negative is outside the function, think about what that's doing. That's making all the y values negative. So if you're making all the y values negative, then that's going to become a reflection. So again, thinking about like all the y values, I shouldn't say negative. That's misleading. You're making all the y values their opposites. So if it were positive, it's becoming negative. But if it were already negative, it's becoming positive. So you get that reflecting idea, but it's over the x-axis, not the y. So it's a reflection across the y-axis. Or x-axis, reflection across the x-axis, because all your y's are changing, okay? So the next one is also an effect of the y variable, right? When you have absolute value outside the function, right? So this creates only positive y's. So this creates only positive y values. So if you have any part of the function that is below the x-axis, so if I use this example up here, if I could pull this graph down and pull just this part down, right? So let's say this is my graph, okay? If there are any components that are below the x-axis, their y values will bounce up to be positive. So if it's already positive, nothing's going to change. So like this part right here will remain the same because its y values were already positive. But all of these values down here are negative. So what's going to end up happening is that you'll get its image up here. So the x's don't change, it's just the y's. So it creates only positive y values. But if the y values were already positive, nothing happens. So it's not a reflection. You're not changing positions, you're just creating behavior of only positive y values. Okay. Now, when your absolute value is on the inside as opposed to the outside, we should be anticipating is only affecting x values, right? And so what ends up happening is that your function's going to behave like the positive x's do. So if your x is already positive, nothing's going to change. But what ends up happening here is that the quote-unquote negative x's will behave, and like when I say behave, we'll have a function value or a y value. So the negative x's will behave like the positive x's. So it's not a true reflection over the y-axis like the above one was, the first one. If you're already a positive x, nothing's going to happen. So let's take a look then at maybe like what might that look like? Just an example, just generically, y-axis, x-axis. So let's say this is your graph, something like this, and then maybe this is, I don't know, something like that. Okay, so there's your function. Okay, now if you are on the positive x-axis, so if you are over here, let's highlight this. Oh, one more time. Pick a highlighter right there. Okay, so if we're on this side over here, okay, so this side already has positive x's. Nothing's going to change, but the things that are on I guess this side have negative x's. They can no longer behave the way they do. They must mirror what's happening to the right. And I like that idea of the word mirror. Like they're going to mirror the behavior of the right. So what's going to end up happening is the graph's going to completely change shapes. It's going to mirror, it's going to mirror that right side. So it's going to look something like that. So, and coming all the way down there. So no longer would it be the existing kind of a straight line segment. It's going to be this curve. And it's okay that it dips below the x-axis because here, these are negative y values, not negative x's. So whatever the behavior of the x's are, great. They don't change. Because think about it. Like, x, when you make it absolute value, if it's already positive, nothing happens. But the negative x's, they will become positive x's, and then they must behave as the function's positive x's do. So both sides will mirror each other, but it'll be dictated by the right side because that is the behavior of positive x as defined in the function. Okay, so those are just general rules for our four basic transformations. Okay, and so what we're going to do now is apply those four basic transformations to different functions. But like the first two examples are actually going to be graphs, right? So in the next video, I'm going to do the transformations for for whatever this particular function is. Let me pause the video and you could try a couple if you want and follow along and see how you do.